So let's talk about the ideal gas law. So the ideal gas law is basically a combination of all the other gas laws. So when we combine those, we get PV is equal to nRT. So pressure times volume is equal to N moles times R times the temperature, where R is what's called the ideal gas constant. And it has a value of 0.08206 liters atmospheres per mole Kelvin. Now, because it has these specific units, the other variables have to have those same units as well. So your volume has to be in liters, your pressure has to be in atmospheres, your moles are moles, but your temperature has to be in Kelvin, in order for the for everything to cancel with R properly. And if you have any three variables, you can always find the fourth variable. Now, before we work some problems, we need to talk about a specific designation called standard temperature and pressure, or STP. Now, STP designates a temperature and a pressure. The temperature is 273 K, and the pressure is 1 atmosphere. So when you see the term STP, that's the temperature and pressure. It's giving you those two variables. So you just need one other one, and you can find the fourth. So if you have volume, you can find moles. If you have moles, you can find volume. Now, one important thing to note is that at STP, 1 mole of any gas occupies 22.4 liters of space. So we can prove this. Okay, so PV equals nRT, R is that. And if we rearrange to solve for volume, volume is nRT over P, and we plug in these numbers that we have from STP, 1 mole and R, and the temperature of 273 divided by the pressure of 1 atmosphere, and you get 22.4 liters. So this is a useful shortcut if you're at STP. It's not necessary. It's never necessary to memorize this because, as you see, you can get the right answer from PV equals nRT. But it might help you if you remember this, if you're doing problems at STP. But just keep in mind, when you see the term STP, that's what that's telling you. So let's do some examples. So first off, if 4.5 liters of a gas are at 3.5 atmospheres and 20 degrees Celsius, how many moles are present? Well, we've got our volume, and we've got our pressure, and we've got our temperature, and we're looking for our moles. So to rearrange this equation to get N is equal to PV over RT. So plug in our numbers, 3.5 atmospheres, 4.5 liters, temperature is 293, R is R, atmospheres cancel, liters cancel, Kelvin cancels, and you get 0.655 moles. Okay. If 0.36 moles of gas, so there's moles, occupies 1,200 milliliters, so there's volume, but I need to convert to liters, at 35 degrees Celsius, so that's temperature, and I need to turn that to Kelvin, what is the pressure? So I'm looking for P. So, rearranging for pressure, pressure is equal to nRT over V. So, just plug all those in, 0.36 moles, R, the temperature 308, and then the volume of 1.2 liters. Moles cancel, liters cancel, Kelvin cancels, and you get 7.58 atmospheres. If 0.065 moles of a gas are at 500 millimeters of mercury, so here's N, P, in a 650 milliliter container, V, what is the temperature? All right, so moles, fine. Pressure, we need to convert to atmospheres. And volume, we need to convert to liters. So temperature is equal to PV over NR. So the pressure is going to be 500 over 760 to get to atmospheres. So it's 0.6, that's a 6, 58 atmospheres. Volume is 0.65 liters. Okay, so we plug those in. Pressure, volume, moles, R, atmospheres, liters, and moles cancel. And you get Kelvin, and you get 80.2 Kelvin, which is, it's pretty low. All right. Finally, if 10 grams of carbon dioxide are at STP, what volume does the gas occupy? So we've got 10 grams, which we can find our moles, right? So 10 grams times 1 mole per 44 grams, right, to get your moles. STP tells us 1 atmosphere and 273 Kelvin, right? And then rearranging to find volume, V equals nRT over P. Right? This is 0.23 moles. Plug it in, 0.23 moles. R, temperature, 273 Kelvin. 1 atmosphere. Moles cancel. Kelvin cancels. Atmosphere cancels. And you get 5.15 liters. Now, since it's at STP, we can't actually shortcut this if we remember that at STP, 1 mole takes up 22.4 liters of space. So we know we have 0.23 moles, and we know that there's 22.4 liters for 1 mole, and we can find 5.15 liters. So again, at STP, you can shortcut this, but as you can see, if you don't remember that, it doesn't matter because you can still solve it using PV equals nRT. So let's do some practice. All right, if 1.2 liters of a gas are at 0.54 atmospheres and 50 degrees Celsius, how many moles are present? Okay, well, we'll start for N. So PV equals nRT. R equals 0.08206 moles, liters, atmospheres per mole Kelvin. So in this case, we're solving for moles, PV over RT. So 1.2 liters times 0.54 atmospheres over 0.08206 liters atmospheres per mole Kelvin times the temperature. So 50 plus 273 is 323 Kelvin. Liters cancel. Atmospheres cancel. Moles don't cancel. Kelvin cancels. And you get moles. And you find it to be 0.024 moles. If 0.91 moles of a gas occupies 2690 milliliters at 15 degrees Celsius, what's the pressure? All right, so we're solving for pressure. So pressure is equal to nRT over V. So 0.091 moles times 0.08206 liter atmospheres per mole Kelvin times the temperature of 288. Kelvin cancels, moles cancel, and then divided by 2.69 liters. Liters cancel, and you get the answer in atmospheres, which is 0.799 atmospheres. If 0.15 moles of a gas are at 493 millimeters of mercury of pressure in a 6580 milliliter container, what is the temperature? All right, so this we need to divide by 760. So we do 493 divided by 760, and we get that this is 0.649 atmospheres. This is 6.58 liters. So the temperature is equal to PV over nR, which is 0.649 atmospheres times 6.58 liters divided by N, which is 0.15 times R, okay, atmospheres and liters cancel, moles cancel, and you get Kelvin, and you get 347 Kelvin. If 2 grams of helium are at STP, what volume does that gas occupy? Well, 2 grams of helium we find is equal to 1 mole. So I've got 1 mole at STP. So if I remember correctly, well, that's 22.4 liters. You could also solve that using PV equals nRT. But again, it really is just rearranging it, making sure you have everything in the right units, and then just plugging it in.